Good morning, students. So today we will be discussing about the converse theorem, that is the converse of basic proportionality theorem. Okay, so those students who don't know what is basic proportionality theorem, watch my other video that is on the basic proportionality theorem. Then you will watch this video, then only you will be able to understand what is the converse of the basic proportionality theorem. That is, it is a prerequisite for the converse of BPT that you should go through the BPT theorem first. Okay, so let us understand what is converse of BPT. So, by converse of BPT, suppose if we are having a triangle ABC. ABC is a triangle, okay, and a line is drawn which is intersecting the two sides of the triangle. Suppose this is a line which is intersecting the two sides of triangle, that is, and this is point D and this is point E. So if it is given that the ratio in which this line DE is intersecting the side AB and AC is same, that is, if AD upon BD is equal to AE upon EC, then this DE will be parallel to BC. This is known as the converse of basic proportionality theorem. That is, if a line divides any two sides of triangle in the same ratio, then this line will be parallel to the third side. Like in triangle ABC, the line DE is dividing the line segment AB into two parts, that is AD and BD, and it is also dividing the second line segment of the triangle ABC, that is AC, into two parts, that is AE and EC. So the ratio in which this line DE is dividing AB and AC is same. That means AD upon BD is equal to AE upon EC. Then, according to converse of BPT or converse of Thales theorem, DE will be parallel to BC. Hope you have understood the theorem. Now let us come back to the proof of this theorem. This is the statement of the converse of basic proportionality theorem. Okay, that is, if a line divides any two sides of a triangle in the same ratio, that is, if a line D is dividing two sides of triangle AB and AC in the same ratio, that is AD upon BD is equal to AE upon EC, then the line is parallel to the third side, that is DE will be parallel to the third side BC. Now let us look at the proof of this theorem. Okay, this is the question, that is, in triangle ABC, this is the triangle ABC, line DE is dividing AB and BC in the same ratio. Then show that DE is parallel to BC. So first step is that we will draw the figure triangle ABC you will draw, and then you will draw DE, and it is given that this DE is dividing AB and BC in the same ratio. So first of all, I have drawn the figure. Then the second step is that we will write given solution. What is given? It is given that the ratio in which the line segment AB is divided, AD upon BD, is same as the ratio in which the line segment AC is divided, that is AE upon EC. This is given, and we have to prove that DE is parallel to BC. Okay, so for that we have to start with an assumption. First, since this will be done by the contradictory method, Contradictory method, we will first do the assumption, and the assumption will be that which we have to prove, that suppose we have to prove that DE is parallel to BC. So we will take the assumption that DE is not parallel to BC, and then we will contradict the assumption. Okay, then we will contradict the assumption. This is known as the contradictory method. Let us see how we will do this. So first of all, we will take the assumption, that is, let DE is not parallel to BC, and if DE is not parallel to BC, then we will do the construction. We will draw another line, say for example DE dash parallel to BC. Okay, so DE dash we will be drawing parallel to BC. So suppose this will be DE dash, okay, DE dash parallel to BC. Okay, now we have drawn DE dash parallel to BC. So we know that DE dash is parallel to BC by construction. So now we can apply the midpoint theorem. By midpoint theorem, we can say that if DE dash is parallel to BC, then AD upon BD will be equal to AE dash upon E dash C. Okay, by, sorry, not midpoint theorem, sorry, by basic proportionality theorem. By basic proportionality theorem, in the triangle ABC, DE dash is parallel to BC, therefore AD upon BD will be equal to AE dash upon E dash C. Since by basic proportionality theorem states that if a line is intersecting the two sides of the triangle and that line is parallel to the third side, then the two sides will be divided in the same ratio. So here in triangle ABC, DE is a line which is parallel to BC and it is intersecting the other two sides AB and SE at D and E dash. So it will be divided in the same ratio, that is AD upon BD will be equal to AE dash upon E dash C. Okay, so by basic proportionality theorem. And second thing, that is AD upon BD is already given equal to AE upon EC. This is already given, that the ratio in which this DE is dividing AB and AC in the same ratio, it is given in the question. So we can write that AD upon BD is equal to AE upon EC. This is given in the question. So make this as equation number 2, make this as equation number 1. Now from equation 1 and 2, we can say that the left hand side of equation 1 and the left hand side of equation 2 are equal. So we can say that the right hand side will also be equal, that is AE dash upon E dash C will be equal to AE upon EC. Okay. Hope this up till this point it is clear. Now we have got AE dash upon E dash C equals to AE upon EC. So adding 1 both side, so what we get? We get AE dash upon EC plus 1 equals to AE upon EC plus 1. And when we add it, what we will get? On adding we will get EC and EC. If we take the LCM, so it will be EC only. EC ones are EC, so it will be cross multiplication, that is AE dash plus of E dash, sorry, this was E dash C. So E dash C equals to, similarly here, upon E dash C. So it will be AE plus of EC upon EC. So AE dash plus of E dash C. AE dash plus of E dash C, if you see AE dash plus of E dash C. So AE dash plus of E dash C is AC. Similarly AE upon AE plus EC will also be AC. We can write AE dash plus E dash C as AC, and we can also write AE plus of EC as AC. So writing that, what we will get? We will get AE dash plus of E dash C can be written as AC upon E dash C, and AE plus EC can also be written as AC upon E dash C. Now on simplification, AC and AC will cancel out, so we get 1 upon E dash C equals to 1 upon EC, or we can say that by cross multiplication EC is equal to E dash C by cross multiplication. So if EC equals to E dash C, that means therefore E is coinciding with E dash. Okay, and if E is coinciding with E dash, so what we can say? We can say that DE dash is parallel to BC, therefore DE will be parallel to BC. Hence it is proved that the line which is intersecting the two other sides of the triangle in the same ratio is parallel to the third side. That's it. Thank you.